Andrew Wilson Kazushi, who's going to go over reverse engineering websites. So let me bring Andrew in now. Hi, Andrew.
Hey, how's it going? Can you guys hear me?
Yeah, sounds good.
Awesome, thank you.
All right, have a great talk and take it away.
Cool, let me just share my screen here. Okay, just as a sanity check, you guys can all see that, I'm hoping. You could say yes. I wouldn't see it anyway, so that's okay. All right. Well, here, let's get started. So first off, thanks everybody for having me. This is actually really exciting for me personally, just because it's the first time I've given a talk in about the last 5 years. And I have kind of stepped away a little bit from sort of the community and the scene for other reasons, but I'm really excited to be able to come back and kind of share a little bit about what I've learned over the last few years and kind of share with you all in general. I guess the second part is I'm from Connecticut. I think it's an awesome state. I love basically everything about it except for property taxes. So if you live there, good luck. But born and raised in Middletown, so it's pretty awesome that the first place I get to come back to and kind of share a talk with is kind of my home state, if you will, and I'm pretty happy to be able to be a part of that. Kind of a little bit about myself. So I work for Bishop Fox. I'm the vice president of consulting services. So basically, all the pen testing that the company does kind of revolves through my department. You know, Bishop Fox is one of the largest privately held security firms doing nothing but offensive security. That's kind of our primary focus. I also started a thing just recently called the Sen Security project. So if you like application security, you want to learn more about it, you know, not just from this, like, how do I get a job and pass like an exam sort of thing, but really learn a little bit more about sort of the ins and outs of pen testing of applications. We kind of explore that a bunch there. I'm a co-founder of CactusCon, so also going to be virtual this year. Please join us. It's in February of next year, I should say, excuse me. So cool to have you join us. We started as a BSides and we've kind of grown pretty big since then, but I'd love to kind of see some of my friends from Connecticut join. For the sake of this talk in particular, though, there's kind of two facts I just wanted to kind of call out, which is one, I was a software engineer for 10 years, right? I spent a lot of time in code building enterprise systems for financials, vertical for academia. I've worked in startups, I've worked for big companies, I've worked for small companies, and I've solved a lot of interesting problems kind of over that time. I was one of the first Microsoft Windows Azure MVPs, and I spent a lot of time kind of in code. The other half of my career, really the first sort of 6 of the last decade, was as a specialty tester focusing on application security, predominantly web applications in general. And so I've spent a lot of time thinking about the problem of how do you do this right? And how do you do this with sort of an engineering mindset? Because for some reason, there appears to have been a bit of a divestiture from web application testing to engineering, as if they're like two separate things. And really, they kind of go hand in hand. They're two parts of the same stone. This particular talk actually came about through a conversation that I had with a guy named Thomas Pacek. If you're familiar, he was one of the co-founders and partners of Matisano. And we talked about the fact that security testing is first and foremost a problem of visibility. And I've always taken that to mean that if you had come to me and said, like, I've got $1 million, right? I've got all the time in the world. I want to go break into this application. I want to really figure out, you know, what the problems are. What would I do? I would say, give me access to the source code, give me access to the server, you know, let me sort of look at something, how user traffic and real data is moving through it, right? I want to see what's going on, because now I'm not guessing, right? I'm immediately in a position of greater advantage than I would be on the outside, because I don't have to like sort of fill in the gaps, and I'm not playing sort of 20 questions in a very expensive, you know, pen test, if you will, right? So if the idea is that is the ideal state, right? If that's what we agree is like, yes, that makes sense, we should be targeting that, then the question is, what do we do in situations where we don't necessarily have that access or have that same level of sort of information available to us? Reverse engineering is just sort of one way to do that, right? And I would say that it's maybe not even the most preferable, because as you get into some of the source code and you get into some of these systems, when you start kind of going down this methodology, you'll find that you can just go download the source code, right? It's publicly available frameworks, and you know what version someone's using, and you can take it down and you can sort of shorten that loop and you can pull it in. And in other situations, you might find that you could target specific vulnerabilities to sort of obtain source code off of the web server through like directory traversal, or breaching the server itself and then grabbing source code. Like, all of those things are just as valid ways to sort of solve the visibility problem. But reverse engineering is the one that I think we're going to talk about today, obviously, right? In practical terms, this is something that is necessary for a variety of reasons. First is that if you don't understand the systems that you're looking at, it's very difficult to understand weaknesses in them, right? I don't really care what you know about vulnerabilities per se, but if you can't look at a system and understand like the composition, it's going to be very difficult to take vulnerabilities and then marry them up to what's actually happening if you have no kind of concept of what's happening behind the scenes. And vice versa, the more you understand of it, the more you can leverage vulnerabilities that you do know about, because you can look at them in kind of unique ways. The second part of it is that you would do it because if you want to write specific exploits for this application or for a web server or website, you basically need information. You need to understand how it works in order to create reliability in those attacks, right? So the more sort of information you can kind of gather in terms of how it's composed and what it's doing, the less guesswork that's necessary in it, which is, again, the value of having, you know, a workable lab or a workable thing on your own sort of premise, right? And then you can go test with it and then use that as a way to validate against something else that you're going after. But I want to be kind of clear as we're talking about this, that when we say reverse engineering websites, we're not talking about reverse engineering like a binary. That process is going to be mechanically quite different for a variety of reasons, right? When you have a binary that you download and you're going to go down this process of reverse engineering it, you basically, for the folks who aren't familiar with, I guess, the term, you have a decompiler which basically takes the state that you're looking at it and it recomposes it into a reasonable representation of code from what it's doing, right? Because you have this intermediary layer that you can sort of work backwards against. But we don't necessarily have that, right? We don't actually have a guarantee of a home court advantage. That's the first thing that goes into it. And what I mean by that is, like, when you pull a binary down, it has to operate in your environment on your computer. And so it's your memory it's talking to, it's your operating system it's talking to. And with that, you have a lot of control around the outside perimeter that you can actually very much watch and understand and see sort of how an application is behaving, and then use that to kind of understand it. And so unless you're downloading source code, like we said in the first place, like you don't have that, right? You're looking out on the outside and trying to figure out what it's doing. The second thing is, it's not always a full picture, right? When you download an application, right, in order for it to operate and function, it has to have source code to do that, right? Meaning that any feature you'd be looking at any given time that is functional, right, you have to have the full scope of that feature set available to you to look at. Whereas in a web application, there's no guarantee that there aren't a bunch of other forces sort of invisibly affecting the way that this is behaving. There is ways to detect that, but you don't always get the whole story, either because you lack that visibility, or you just lack the fact that it's not on your computer, right? It's not on your computer. And then the last thing I'll say is that there's no real set standards. There are standards, but they're kind of more like the in quote standards of, like, we said this was a good idea, and then like some people followed it, but I wouldn't necessarily call it like a standard. A binary file, when you pull it down, has to meet sort of a minimum contract, a minimum criteria of execution, right? And it might be very difficult to discern how it operates or what it's doing, because they have a bunch of countermeasures and things like that deployed. But the reality is, it has to follow those, or the operating system can't execute against, right? You know, code has to meet these minimum constructs. But when we look at a website, we do have some rules, and we're going to talk about those rules, but we don't necessarily have them in a set like this is exactly the way it has to operate, or it doesn't work in the same way as we would talk about a binary file. So our process, right, of testing is going to revolve around three basic ideas. And the first of this is a thing called recognition prime decision making. So back in sort of the 80s or early 90s, a gentleman named Gary Klein bid for a contract with the US military because they were having a problem teaching field commanders how to go solve difficult problems that were time gapped, meaning they had to solve them relatively quickly. And they didn't necessarily have complete information to make those decisions. And they had just gone down this route of like making like a flip chart that said like, if this, go look over here, and if that, go look over here. And it failed. Like it was awful. And so Gary Klein and his team wrote about this in a book called Sources of Power, about this exercise they underwent to try to help the military learn how to make decisions better, basically, right? And so knowing that the problem was time gapped and incomplete information, they took a look at people who had a lot of experience with this already. And so they went to firemen, they went to nurses, they went to chess players, and they looked at how they solved problems to understand what was going on in front of them. And across the board, they all basically came back to Gary Klein and their team and said, I don't know, I'm not making any decision, right? I just look at it and I know, right? Which is fundamentally awesome, but also super useful, right? Useless, I'd say, because that's not a testable method. But when Gary's Klein team sort of got into it, what they realized was that they aren't in fact making decisions. They just know what's going on because they've taken the time to understand the sort of lever points that actually affect the outcomes that matter, right? So firemen are very versed in how fires work. They look at how smoke behaves. They look at how fires start. They understand a lot about buildings, so that when they're actually trying to solve a problem of going to a fire and identifying what's going on from an outside, they can take all of the different factors that affect how this is going to behave when this sort of combination happens, and they can look at it and go, well, this is probably going up an elevator shaft. It appears to stop on the 4th floor. Maybe there's an obstruction. You can see how the smoke behaves different. And you could do this almost instantly, right? This is almost like an instantaneous pattern recognition model. And for anybody who's done something for a long time, I think that's going to feel very natural, which is why they call this style of learning called naturalistic decision making, right? It's very similar to folks who are familiar with the OODA loop, which has the same premise of you observe what's going on, you orient what it means in your head, you decide an act, and you repeat. But the actual model itself in our case is following kind of this pattern over here, which is it a familiar situation? Yes or no? If it's no, then you do a lot of seeking information, reassessment, and there's sort of a loop over here. If it is familiar, then you watch to see how it's executing and you determine, like, is it meeting my expectancies? Is it behaving the way I want it to? Does it have the relevant cues that I'm looking for in order to confirm that is in fact what I think it is? And then you decide, right? And that decision part also has a loop, which might say either A, I already know what this is, so I can go test it and I can go do something with it, whatever that is. Or I don't know, I know what it is, but I don't know how to solve it. And you might go through this like mental game of like scenario play in your head to go like, here's some ways I could solve that. This actually turns out to be one of the core pieces of this. And I want to just call out that it's really difficult and to sort of learn over time, but it's super useful. And if you don't have this expectancies, if you don't understand the situation being familiar, it can really kind of lead you astray as you go down the path of understanding how code works, where you won't be able to know the difference between custom code or code that they've developed or architecture, or even just other interactions that are happening in it, because you have no expectancies, you have no cues, and you don't know how to sort of measure the mismatch of what's happening in it. And the best way to explain that is like a couple of years ago, back before Google was sort of ubiquitous and like cellular service was not so great, I went to go visit my friend who had just moved up to the Pac West, and he'd given me these directions on paper and I printed them out, and it was perfect directions, right? It was like, get off the freeway, come over here, and you get to like the last step, and it was, follow this until you hit hidden something road, right? And hidden road. How far away it was, I don't know, right? It's dark. It was nighttime when I got there, and all I know is it's a road, right? It says hidden, so maybe I'm thinking it's like a small side seat or something like that. I kid you not, it probably took me an hour to an hour and a half to go 2 miles down the road because I had no idea what it was. I had no way to measure the delta. I've literally every road you see, whether it's left or on the right, you're like, is this it? Is that it? And it was pretty disappointing because when I finally got there was a huge sign that said like, oh, this is the hidden area that you finally arrived at. I was like, oh, you jerks. Like for an hour, I've been looking for this thing. But that's the problem when you can't actually use patterns and you can't use this sort of expectancies to solve problems, is it makes you have to go really what would be this kind of loop up here, repeating over and over and over again until you get there, right? The second part of our reverse engineering is going to rely on sort of the scientific method, which is sort of part 1 and part 2 of this. which is the inductive method and the deductive methods, right? And just scientific method would be a better way to kind of look at it. The inductive method is best probably described by Edmund Locard and what he called the Locard's exchange principle, which basically says you can't do anything in this world without leaving evidence of how the action was performed. Even if what you're doing is trying to hide evidence of what you've done, the lack of evidence and how you hide the evidence leads evidence. And it's very likely this transference sort of principle that you can, with enough clues, figure out backwards what happened inside of it. This is like the Sherlock Holmes like epitome of sort of statement and from a forensic science perspective. The deductive method is more of like a reductionist method. This was from the Rene Descartes, and he talks about this idea of like a general theory and then an application. And if we know like X is true and Y is true, then the other one must be true. So like in this example, it's like all men are mortal. Socrates is a man, therefore Socrates is mortal. And you can kind of use a general theory applied to a specific person and then make assertions about who that is and how they have to operate based on those sorts of things, right? So with that kind of in mind, right, with that kind of premise, let's talk about patterns, right? Because we don't, even though we don't have standards, meaning you're not obligated to compose an application on a web server a certain way, there are some fundamental problems you still are kind of up against. And this is probably the best explanation I've ever seen on this, which is applications fundamentally have to solve three basic problems, right? The first is that anything that they are doing, they have to present back to you. So there's some interaction with a user, which is typically your presentation tier. It could be a command that you're sending into the application that says, hey, go do a thing for me, or go show me this information, or maybe I send data because I need to store it. But ultimately, some sort of interface, and that could be as simple as like a terminal, or as complicated as a web application or a desktop application or a very distributed application. But that would be sort of conceptually what we all call this presentation tier. The second part of it is that you have to have some sort of underlying logic. So like if you make the get total sales total, there's like a function that would correspond to it and go, okay, like what are the permissions this person has? What are the sales that they're trying to reference? And it follows like a routing workflow system to kind of check and aggregate the stuff that would solve it. And then it's going to go request that from your persistent tier, your data tier, or then some storage thing, right? This is sort of the fundamental problems that everybody sort of would have inside of building an application. This could be as simple, by the way, as like 5 lines of code or 10 lines of code, like in one little application, right? So they can kind of get really blurry where your logical tier is shoved into your presentation tier, which then directly accesses a database or what have you. You can have cases where they pull all the logic tier and shove it into the database, and you're just talking about a sort of thin veneer on the database. But these are common patterns, and they're all still taking into consideration sort of logical problems that have to happen. From like a modern perspective, websites kind of sort of behave like this, especially like high availability, highly scalable web applications. This is sort of something that you would see, right? You're going to have a load balancer that's going to distribute kind of how things come in. You might have a hosted zone that's specific to like a geography or a particular subdomain. The web servers will scale up and down, and so they'll distribute horizontally in order to correspond and talk to an app tier, and then your database kind of at the bottom. The couple of things that are here that weren't in the other one was this sort of caching tier that's this is a cache, and in theory you can kind of think of this as a cache, which you basically distribute static information or information that doesn't need to necessarily make what we call a round trip to the database and then back all the way up through the chain. Because it hasn't changed, right? If it hasn't changed, there's no need for it to go all the way down and all the way back up. And then the other thing that's here that's not in the other one is sort of this monitoring network, which says, if I build a thing like this to make my cool, awesome website, I kind of want to know what's going on with it. So I'm going to have alarms, I'm going to have notifications, tables, etc., and they're going to give me insights inside of it. So even though you can't see them, even though they may not be accessible, this could be internally hosted, this could be in a separate like whole zone. You know that presumably it exists and that you can actually anticipate that those things exist, right? So that's it. That's all I wanted to say kind of about some theory. And then I figured the best way to kind of do this was maybe to pick on something and take a look at it, right? First, I'll just like clarify your normal warnings is that this is not a pen test against Wikipedia. We're just looking at source code. We're going to make assertions, right? We're not doing any testing of any sort. No kittens were hurt in the making of this presentation, right? We're just playing with it, right? We're just taking a look. The second is because it's not a pen test, because I'm not actually breaking into it. This is in fact something that's like just we're picking our target for our own sake, right? Theoretically, when you're doing this for an engagement, knowing, like I said, security is a visibility problem, I might have a set of priorities that I'd go after. In this case, I'm just decomposing it for the sake of exercise and learning. So normally would be a little bit more directive than what we're going to do kind of here. So with all that said, right, with all that said, we already know a lot about Wikipedia before we ever even look at anything else inside of it. You know, first there's the landing page, but just in general problems, we know that Wikipedia has millions of articles, right? Just millions of articles written in multiple languages, distributed to multiple different languages, meaning that the French version of Wikipedia and the English version of Wikipedia are independently growing because there's independent articles on it. So it's actually pretty safe to assume from a general theory working our way down that these are separate entities, meaning like the English instance doesn't also contain the French instance or the Dutch instance, but they probably independently grow, even though they might really legitimately all be on a similar, if not the exact same code base for each one of these sort of units, right? That's the first thing we know. The second thing we know is it's super highly trafficked, right? Wikipedia is, I think, the 9th most popular website in the world. You could do basically anything on it except cite it academically while you're writing research papers, but it's got information, out there. And we know that it's got to solve some real problems like scale. So we can take this general idea of like its size, its frequency of use, the geographic problems that it has, and I'm just going to make posits, right? And again, I didn't cheat and like look at source code and look at all this stuff because again, it's open source. I didn't do any of that until sort of way later, but you can actually assert very basic things like they probably have a huge investment in a caching infrastructure. They probably geographically home people as they go through the website to content networks that actually make their life a little bit easier, which are going to determine how the servers scale and what you're talking to. And you can start testing for that, right? And that's my point, is that we started with knowing nothing about Wikipedia other than that it exists and there's some concepts, and we can just start with general problems that it has to solve right from the get-go, right from the beginning, and then we can test it, right? And so we did. We pulled the first page. This is actually the response body for the previous page, or the response headers at any rate. That's interesting. And what it proves basically right off the bat is that it's cached, right? It's served out of this Apache traffic server, the 808 version. It has this other caching mechanism, this 509, where it hits here, and then it basically knows that this is serving out of that. The second thing it actually kind of reveals in the header is that it also has this sort of external logging endpoint that it's actually pushes data out to in terms of network events or network errors. How that comes into play, we don't know, but immediately we know it exists, and we can start even just on this to build a mental map of how this thing works. The other thing that it does is it throws a cookie here that tracks sort of when I came last, and it's not actually on this response simply because it was actually the 304 not modified, so it didn't reissue the cookie, but I had already come to it, and it gives you a geographic home. So it shows my IP in a header, and then it shows my IP, and it captures it in a cookie, and then it uses that cookie to make decisions, right? Which is a lot, right? We learned on one request that my assertion about the cache is true. We identified a technology of a cache. We figured out how they're likely tracking it. We don't know how yet to get to real servers, right? So when we think about caching as a problem, we go, okay, well, I want to get to data that's not cached. I want to get to real data. You can actually still take that exact same principle, and you can kind of make questions like, what if I create new content? Can you cache that before it serves? What if I'm requesting things that are unique to me? How does it serve dynamic data? And you could take those as sort of theorems, if you will, and say like, these may not be served out of cache. It's possible. And you can start using them to create a testing plan or sort of an exercise to understand how it's actually making those compositions inside of it, right? So, we don't know if there's other servers. We don't know how to get to the real servers. We don't know how geography affects where we land. So if we click kind of on the English page, again, like I said, assuming that this is probably an isolated instance, we can kind of walk into what is this sort of landing page here. And this is interesting, right? Because it's not an article per se, right? It's not like a specific article, which we would assert may not be changed super frequently. It gives me recent news. It gives me today's articles that are featured, stuff that's happening right now. And so we could kind of guess, right, practically speaking, that this would be served from more of a dynamic fashion. And we would be basically wrong, right? I'll say that, right? What is interesting about that request is that when you go to the enwikipediapage.org, this particular page, it redirects you out and it serves you from a whole other server set that's not the Apache traffic server. We've gone somewhere else. In this case, it doesn't cache the request because it's just a 301 move, right? Which is most likely happening at the server level. And then it has and it adds onto this request ID, which is tracked for logging, right? So if we're thinking about our first request, we know they have a logging infrastructure. We actually also kind of already know how they're doing the logging, or at least some mechanisms of what they're tracking, because that request ID is probably a correlation ID that they're going to be looking at errors against and they'd go back to if you have problems. But one of the things that's interesting on this is that when you land on the page, you might have noticed that I requested this main page here, right? This was the URL. And instead, when you look at the view source, it actually retrieved it from a whole other page, this enwikipedia.org with the w/index PHP controller. And when you look at the two pages kind of side by side, this is not the same main page. This is two pages that serve the same way. You can see that it's exactly the same traffic. It's totally the same. There's nothing sort of different here. And we got to start asking questions about what's kind of going on. So kind of back to theory. A guy named Martin Fowler created a book. I want to say this came out in like the 2003 timeframe, called Patterns Enterprise Application Architecture. It's very related to some of the original pattern books that came out, the design patterns by the Gang of Four group, that says when you write code, there's only a handful of ways in which code gets distributed and we solve problems, whether it's intentional or not intentional. There's sort of these patterns that people follow as developers, and even trends. If you are a developer today, you'll see that there's trends that modern developers do that maybe older developers or people who've been around longer may not follow or have some variation against. Well, so what he calls out here is that this index.php page is most likely being served as a thing called a front controller. So a front controller basically means that when you go to that page, this index.php, this is going to operate as a routing mechanism to the actual functions which probably exist beneath it as a do edit or a do history type of call. And so you're going to have page, right, the action that you're going to call one of these folks, and then the parameters that get passed into it, basically the way that you would control variables of it. We also know that because it's supporting this index.php piece, that the second call is most likely some sort of regular expression or alias map to that call, meaning that whether at the service layer, the server layer, or whether on an app tier layer, there's some sort of like routing mechanism in between that says, hey, when you request something that looks like this, what I really want you to do is I really want you to map it back to this index.php page. And given the frequency in which it comes up, understanding a little bit about the history of PHP and its development and things of that sort, you could reasonably assert that the index.php page with these sort of sub-actions are probably the core framework of MediaWiki, right? This is most likely how the rest of the page is put together. But I will call out that it's interesting because when you make the difference between my URL rewriting and then my direct call through the sort of functional query method, you now have expanded your scope of attack actually in two ways, right? Because for folks who are not familiar, there's a standard here. I think this is the RFC 1738 maybe, that breaks out how this kind of goes out. You have schema, like what you're calling. You can pass username, the host, port, etc. But kind of towards this tail end is where it gets interesting, is that you have a path and you have a key value in a query. And this path and this query do not behave the same way. Meaning, if I wanted to call a function and pass into it a parameter that was path/data, I can't do that in the path, right? I can't say, hey, go get path/data/path/data, because the URI is going to route entirely different. But in the index.php page, I could actually pass, like, for instance, the title name of it back modified in ways that it wasn't anticipating, simply because it now exists as a part of a query string and it's not a part of the path variable and the path parameter. And that becomes even more complex as you start thinking about the problems that it has in sort of that deviation, right? If you're a person building a web application firewall and you have to map these variables out in order to check it for problems, you now actually have two very different sort of ways to access a site that might represent two unique problems, all just in what is fundamentally a really basic design sort of consideration, right? But it gets more interesting, right, as we kind of go through our page here and we look at Wikipedia. Is one of the things that pops up in the burp history here is you see another page called special download as PDF, page equals page name. So I saw that my main page and then this user page actually shows up here, the downloaded as server side. And when you go to that request and you play it out, you'll notice that it will give you both of the exact same pages that we had before. So if you kind of go back a little bit and we look at this page, you can see that this is now served another 2 different ways. I now have 4 ways to access the exact same page, both as a PDF and as an HTML. And when we map this out, if we start playing again, we've looked at the general theory, we've looked at the clues, we can actually put together almost a functional map that would say something like this, is that when you go to this URI here, there's some sort of rewriter here that has to have a regex function or an alias function in order to map it and correlate the request somewhere back here, right? And if we go directly to it, we sort of bypass it, meaning that this doesn't exist. If we go here, something even more interesting happens, which is number 1, the server is now making the request on my behalf, not me. I'm not making that second request to this page. This happens as a part of this piece here. So if you're testing for things like server-side request forgery and you're looking for opportunities to go after it, like, I actually have identified a very reasonable route to start testing for confirmation to see how it would work and what it would do. But more specifically kind of to it, it means that there's probably also a PDF converter, right? And some way to convert the content that would come out of this to go through it. And all of that now becomes very testable, right? Behind the scenes, even though I have no idea what their implementation looks like. I don't have to know what their implementation looks like. I know the problem of I clicked here and it went and got this and somehow I got a PDF, right? And if that's all true, then the existence of a PDF converter has to exist somewhere in that context, right? And we can start playing with it and you can start testing it. And those become sort of real vulnerabilities we've seen in web applications in the past. You could use this like server-side request forgery. Does this call a web request? Does it bypass this function and maybe call it out of a database, right? Again, we don't know, but those are things that you could start testing as you kind of go further and further into the decomposition of this and start kind of playing with it and going from there. Which is a lot, right? We've basically looked at what amounts to 3 or 4 requests, and I can tell you the language of the website. I can tell you its core request patterns. I can tell you the names of some special functions. I know that the index.php page is likely how everything serves for articles, and so if you go to one article, it's basically the same like going to all of the others, unless they have special functions on them, which they were so convenient and nice to call special function, do things, special log here. And so it kind of saves you a little bit of time in terms of figuring out what's unique. We've identified a super user account. That guy blocked me because I was pretending to be from Japan, but whatever. And we don't know things like what are all the other pages. We don't know what other actions each page supports. We don't know how the edge nodes match or understand the request pattern differences because there's now 3 or 4 ways to get it. We don't know what their coding protections are, but all of that is stuff we can actually test for, and we can create more questions and more questions and more questions based on this to start building out further our kind of mental map, if you will. Maybe specifically picking on the fact that we still haven't figured out how to serve cached content. What I'd say is I went backwards and I looked at anywhere the cache missed. And when I went through, I found another front controller called load.php, which seems to be targeted specifically around the idea of dynamically loading JavaScript on the page, which again makes sense, right? Some of that could be cached. It could be that this request in particular maybe isn't something people frequently call. Maybe it's something that has custom content in it for me, for the thing I was going to do. And so it didn't serve it out of cache. It served it from a miss here, and you can see a miss, and it says, hey, we bypassed the cache. But because I'm here, right, on this, oh, sorry, I went wrong button, MW, the 1364, what have you, I know that that has the ability to serve content, even if it's not being served out of cache. So I actually know a fair bit now about their hosting environment, more than they were sort of anticipating. Kind of going back to our front page, when we looked at this guy before, one of the things that I sort of jump ahead a little bit and skip in the context of this is that it actually gets served on a whole other framework that's different than every other part of the site. So it actually comes out of this API REST v1 page summary component. It's a change in technology, right? REST is representational state transfer for folks who aren't super familiar with it. It's a very popular way, or at least it was a very popular way to serve like an API data right back out using things like post and get and headers to control how are you getting the data out of this sort. And so it means that, I know, frankly, they probably requested this through JavaScript. I know that down here, at least according to them, what functions it supports. I know the spec that it's being rolled against. And I also know down here that it's served on a whole different server. This is not even on the same framework. There's a whole other infrastructure component that it's going to give to me as we go through this, right? The other thing that come out that was fairly interesting and sort of very dynamic a little bit as we went through it is that they have this thing for a beacon, right? And the beacon in and of itself is not actually terribly interesting, right? Again, this is probably just a one-way push that says, hey, you went and updated it and here's some data, but it's yet another change in technology. So it's not a front controller. It's not a REST controller. This is something that we actually would call a page controller, which we'll talk about in a second, but I'll call out just before we move on again, there's now another framework. There's like a whole sort of other framework here that didn't previously exist inside of it. So now I know another caching entity, right? A page controller is not a front controller in the sense that typically the page is the action. So if you're familiar with legacy programming languages or you've seen in other places, you might actually have the page named as an action, like the do edit or a do update or do delete or do create. And inside of these sort of statements of actions, what typically happens in a page controller is that in and of itself, it is its own sort of function, its own ecosystem. And meaning in this particular context, that means that there's really probably no other way to access what's going on in the beacon without actually going to the beacon page, meaning it's not a part of a bigger scheme. And you can actually imply that it's maybe an additional extension to Wikipedia, and you can assert that it's probably added after the fact. And it's something different, right? Because it breaks the convention, it breaks our patterns. They are likely to have some very specific behaviors, meaning that the beacon is not something that the rest of the site needs to care. In some cases, it'll inherit a base code and it shares it out, but that's typically what you would see if someone designed nothing but page controllers. So like if you had a whole bunch of common code that needed to be pushed up into the presentation tier, you'd create a base for it. But in this case, because it sort of exists in a very like almost aberrant sort of way to the overall picture, we don't know, right? It's probably just in and of itself its own piece. So we've looked at it basically on 5 or 6 requests. And in the 5 or 6 requests that we've taken a look at Wikipedia, I actually know a whole lot about the potential architecture. I know that they have a ton of edge content that's served through the ATS 808 system, right? We know that there's probably this caching tier underneath that serves and it enumerates up and down numerically, which if you looked at it, you would see that it would grow. And we know that there's a backing server behind it with the MW servers that are going to up and grow numerically as well. We know that that's probably our primary code body, which is the front controllers. And then we also know that kind of off to the side, right, there's an interaction between these pages here in the front controllers and this sort of RESTful service, this RESTful API, which also enumerates, up and down numerically. And then we also know that there's a varnish server or set of varnish servers for this beacon. And with all of that, you can actually do a lot, right? Now, I'm sorry, and the last thing we know is this sort of logging framework over here. We didn't actually get into how it logs. We didn't get into all the conventions and all the pieces of every kind of thing inside of it. But we know it exists. We know that it's a possible target. We know that it's capturing information and transferring it there. But we know of its existence. And so we could actually, like I said, continue this process of decomposition until we have a fairly well-composed picture of how their infrastructure looks, just based off of really a handful of requests and a little bit of process inside of that. For folks who are maybe not as sort of key versed, if you will, in the context of how to do some of this yourself, I would call out and just say, like, look, there are some tools that support that. You have a thing called Wappalizer. It's not necessarily the best thing on the planet in the sense that we went to the same page and all it identified was that it's MediaWiki, which we already knew. It has a cart functionality simply because they accept donations. And then we know sort of the jQuery and we know how the UI sort of works in the context of this, right? We know some of these decisions here. In our cases, those things don't necessarily have a super strong implication in terms of how the website works, but it gives you that rate off of it. And that's off of one request, whereas we took a look at 3 or 4 and we were able to generate almost like half of a network map in just a question of a couple of minutes, right? It's just, it wasn't necessarily even that sort of big of a stretch on it. So that's really the kind of the gist of the reverse engineering process. In the context of Wikipedia, if we were going to go down the route of turning this into something from a web exploitation perspective, or something that we would do to go kind of create attacks, you could actually take this and go even further, very topically or very specifically in it, right? So server-side request forgery in the PDF download functionality, it's making requests on our behalf, which is very interesting. We don't know whether it's an HTTP request. It could be served out of a database, meaning that in some models, what you'll see is that the source code actually gets shoved into the database, and then it's interpreted on the code and on the server in real time, and then pushed back up into it. But we don't know that. We could test for it. We could kind of continue to decompose it, but we actually have a pretty good starting point for where we might want to go for attacks that look like it. We also know that if you're kind of looking at cache poisoning and other HTTP like splitting based attacks, there's probably a lot of ways to bypass it. You could actually explore inside of it. I know the server infrastructure inside of it to make the requests. I know different aspects of how the server infrastructure behaves. We were able to see relationships between all of the servers and how they kind of communicate in terms of where topically they live and what problems they're solving. We know that other functions are interesting. So if you go back kind of to this slide here, you'll see that if we take the assertion that this is my functional map here, meaning these are my pages, the title equals what have you, everything else kind of shows up here as a parameter. So if you're like a good pen tester or bug bounty person, what you might want to do is notice that like this return to actually exists on a lot of different pages. And so do some of these other ones. Well, how much of them, I don't know, but you could actually make a parameter map based on the way that it exposes it, and then re-request and iterate with a very high likelihood that some of these are cross-functional and a variety of the other pieces that are going to affect the behavior of your overall site. And with it, you could actually create almost like an exports list of the functions and how the parameters look and what it does simply by taking what it's telling you and then continuing to kind of dig and dig and dig and dig and dig and dig, right? And the last thing you can kind of take away from this is that, there's this logging service, right? And this logging service is possibly, right, if you're going to go after second order attacks, you have to think about where the data is going and who would be used. And with that, is it possible to sort of like poison the log or poison like live chats is where you might see it in other cases. But in this case, we know that there's a logging service. We know sort of kind of how to talk to it in some regards. And you could actually decompose even that by looking through your request processes, trying to cause errors, trying to cause network errors, seeing how those are going to go back into it and how it requests back out and what it does. And then now we know where you might be. We might know how to go after it and what we can do with it. And that's it. That's the whole sort of concept of reverse engineering web applications kind of in a nutshell. But we still sort of learned a lot. And I want to just say, like, we've really only kind of scratched the surface in terms of things like patterns, because patterns are complex. And we're talking about basically server distribution and how that goes out to the internet and how that works. But in all reality, you still need to learn about things like, how does a browser work, right? How does a browser engine work in sort of rendering a DOM in the context of the browser? You have to learn the interplay between the render agent and the browser itself to get into some really advanced like cross-site scripting attacks and taking advantage of DOM differences in terms of how they execute either at the rendering agent or in combination. You have to learn about new design patterns, right? So Martin Fowler talks specifically about a thing called a front controller, a pages controller, and MVC. Those were kind of like the 3 big ones at the time. But since then, Flux has come out. Since then, we have React, which is basically a single page that operates as its own sort of functional operating sort of thing inside of itself. And while it looks sort of like representationally, if you look at Burp Suite in terms of network requests, it's its own page in and of itself. And so like, taking the time to go learning those patterns is in fact the only way to take advantage of a methodology like this, right? You can't learn how to make decisions like an expert unless you're already an expert. That's the sort of statement. But I can show you what sort of things you need to value and what sort of leverage points you have to kind of learn in order to take advantage of that as you continue to go down this road, so that as you're decomposing a web application, you can figure out kind of how it operates and what it does. The scientific method still rules, right? You can't hide what you've done on a website, even though in some cases you might want to, right? I was sort of joking that maybe Wikipedia has a lot of baggage because it looks like a bunch of legacy code intersprung with a bunch of newer code, and with that creates unique opportunities, but they can't hide that it exists, because it's, in order for it to function, it sort of tells you a lot about what's kind of happening in that. This other thing you could take away from it is that you've got standards, and when you violate those standards, you create ambiguity, right? So if you want to learn more about standard bodies and what they actually say that you're supposed to do, and the sort of browser decisions and server decisions that go into it, there's a book called The Tangled Web, which I highly recommend everybody to kind of read, that breaks out the different protocols and standards that kind of compose a browser, what a browser is trying to do, and the ambiguity inside of it and how it's used and how that creates opportunity. Phenomenal read, which is kind of a lot of how this sort of lets us do that testing. And then last, of course, but not least, is that when you increase the code patterns inside of an application or a set of applications, you actually increase the amount of opportunities a bad guy has to go after it and do attacks. And so as we saw in that, we have literally 4 ways to access the same content. We don't know things like, how is authority derived? Can I access potentially private pages because my authority and its impact of authority is not passed along to the method body? And so with that, you could kind of continue to go layer after layer after layer, and then make more assertions about the underlying piece, because they've created new opportunities simply in some of the design decisions that they've made, and how they exist and what they're doing. And with that, that's really actually it. I kind of got through it a little faster than I was anticipating, but I kind of, that's the pros. That's what we do, and that's how you can use it to go. Now, I know kind of done with that, but I'll offer one thing is, like, when you're reverse engineering for attack, you're typically not necessarily trying to understand the universe. You're just trying to understand enough to operate inside of that world in order to make better decisions, right? So I know we kind of like did this sort of journey together where we looked at servers and request processes. But like I said, my approach to pen testing this sort of stuff has always been very opportunistic. So like, I would go after a site like Wikipedia, or any site really, with the goal of reaching the web server as my like primary target. And so typically my decomposition focus is going to be very specific to those activities. So I'm going to look for directory traversal, the areas where directory traversal might look, any way I can get access to exposed source code or secrets. I'm going to look for file upload based vulnerabilities, specifically to see if I can get things onto the server or take over the server. Because again, my goal is not to try to like read all the source code, backwards through this reverse engineering exercise. I'm going to reverse engineer only within the pocket of nature to understand what it is I'm attacking, and get enough information necessary to leverage that against the server to use it for very advanced and very custom, unique exploits to that situation. So I guess with that, again, like I said, I got through it a little faster than I was expecting, a little 4 minutes. It gives some time for Q&A. So if you have questions, I'll stick around and we could chat. If this is something that's interesting to you, I'm going to be putting together like an actual training course to do a lot of these exercises. Chat with me, and let's see if we get you in on that. I'm trying to do like a pilot class where I'll probably do it for free the first time and get some feedback from everybody. But again, thanks for having me. Really excited to be back. Hello, 47 from Middletown. Exciting to see more people from Connecticut, and thanks for having me. So that's it.
Thank you, Andrew. That was great. Does anybody have any questions at this point? I'll leave the opportunity for questions open for another minute. If anyone has anything to ask Andrew.
Looks like there is a question here that says, what's next for applications? Even thinking we find mobile apps, but for this question, how do these concepts today apply to other current applications and future use of tech? What is also for web services and next for testing? You can use all of this for any of that, right? This is a process that is generally applicable for figuring out how a thing operates and sort of works inside of it. And we use this often in decomposing mobile applications in the same way, where we don't necessarily have source code, but we do know how it operates. And right with that, you can kind of take the same idea of like, relationships between code bodies, relationships between data, how the data comes in, and you could still create this sort of pseudo functional map and then work it backwards to do it, whether it's a mobile application or a desktop application. In fact, what I'll say more specifically on it is there's a great book called Practical Malware Analysis. And in that, they talk about complexity of malware analysis and some of the things you might do. And one of those is to just not even try to reverse engineer, but to put it into an environment, watch it behave, and then look at all the outputs of how it behaves as a means to determine what it's probably doing, right? And depending on how far down that rabbit hole you want to go, you can take that same approach in other applications and use that as a way to determine what it's behaving, whether it's malware or whether it's a desktop application or a web application even. You can actually use that to figure out a lot of the composition techniques inside of it too. So same. It's the same general applicable process. Mechanics are different, but it's the same process. And REST did change in popularity. It started in 2000. It was around for almost a decade. It became really popular in 2008. It was sort of the way to create services from like 2008 to 2010. People dropped SOAP. But since then, I think people have now moved to like GraphQL and other services as maybe being a little bit more popular than REST is today in terms of state behavior and state modification. So. Cool. Sorry, any other questions? I just saw that one from you, Andre. Awesome. Well, I'll be hanging around, and feel free to reach out to me either on Twitter or after, and I'll be hanging around for a little bit.